Hi. So suppose in this array, if someone told you to sort only this part of array, if suppose someone told you to sort only this part of array, only this part of array, only this part of array, or the complete array, then in that case we can use insertion sort algorithm. And it is the best algorithm to sort a specific part of array. Hi, I'm Yash, lead Java developer at IBM, and today in this video we are going to see insertion sort algorithm. Okay, let's see insertion sort. Now, what is insertion sort? The bookish definition is you need to insert the element at its correct position. See here, this is the array given to us. This is the array given to us. Okay, and if suppose, okay, and according to the algorithm, and according to the insertion sort algorithm, it is first you need to take this array, sort it. Then this array, sort it. Then this array, sort it. Then this 1, 2, 3, 4, sort it. And then finally, sort it. How you will sort? You very well know. You very well know. We've already studied in bubble sort. See, we are sorting a specific range of array. And it is only possible when we take two pointers. The very best and famous technique, two pointers. Okay, so I and J. Now, how we will proceed and why we are doing it in this way, we will see in the later in this video. Okay, so this is what all about insertion sort. Okay, we need to follow this procedure. Okay, now let's see how we will achieve the insertion sort and how we'll write the program. Okay, how we will convert this all algorithm, this all concept definition, like we need to sort this array into the program. Okay, let's see it. So this is our array. Okay, let me take it in a new page. Let's take this array 5, 3, 4, 2, 1, 0. 5, 3, 4, 1, 2, 0. 2, 1, 0. Okay, fine. Not fine. 1, 2, 0. 1. Okay. Now, I and j pointer. I equals 0, j equals 1. Okay. Why j is greater than always 0? Why j is always greater than 0? Because we will see. Now, first, according to the definition, what I told you that we need to first take a specific range. First, we will take this range and then sort it, and then this range and then sort it. Similarly, okay, fine. So now, first we will take this range. Okay, this range. That means I is 0 and j is 1. Okay, and we need to sort it. How we will sort it? Now we need to. The important point is, just listen carefully. We need to check all the left hand side value of j, and if suppose here is the j, okay, here is the j. Now we need to check all the left hand side one by one. Okay, so j is 3. We need to check if the value previous than j, if the value, this is the value previous than j, is greater or less than. If it is greater than, then swap it. So the array will become 3, 5, 4, 1, and wait, 2, 0. Okay, now j comes here. J comes here, right? See, j initially 3. 3 belongs to j. Okay, and 5. Now 3 is smaller than 5. We have swapped. So this is j. J comes here. J comes here. Okay, fine. J comes here. Now j is at 0. Is there any element before 0? No. Array index outer bound exception. That is why j always greater than 0. Okay, got it. And I always less than n minus 2, less than or equal to. Okay, n minus 2, j here. Yes. Okay. Let's prove this condition. We have already proved it. Why j always greater than 0. Okay. So this is what we have done. The first pass. This is the passes. The first pass. Okay. In the second pass. First pass, we have sought one range of array. What is the range? This range. After this, we will move I. Initially I is 0. Now I becomes I plus plus, that is I 1 0 plus 1, which is 1. Okay. So now the array is 3 5 4 1 2 0, and I is here and j is here. Okay. So now in this array, I is here and j is here, and we will take now this range of array. Notice one thing. Notice one thing. If I is x, okay, if I equals x, then x plus 1 range of array sorted. If I is 0, then 0 and 1. Okay, these two are sorted, right? 3 and 5 sorted. If I becomes 1, like I is initially 0. Now if I becomes 1 here, then these three sorted, means 0 1 2. So if I is 1, then up to 2 the array sorted. If I is 0 up to 1, that means I plus 1 array part is sorted. Okay, so remember this is the node points. Okay, and it's very useful in not in this theory. It is very useful while solving the problems. The problems we are going to solve after this video. After this video, we are going to discuss cycle sort, and along with the cycle sort, Google, Amazon, FAANG company interview question we are going to solve as we are doing in binary search. Okay, so let's see after this step. This is the pass one. We have sorted this. So now, okay, so I'll not write this pass one. I'll write this as a pass one. Okay, now pass 2. I becomes 1 and j here. Okay, why j comes here? Because we are using 2 for loop. Okay, we are using 2 for loop. Now when j comes here, that means j is at the first index. Now j can't go before it. So loop end, the j loop end come outside I plus plus, and then j equal to I plus 1. So j comes here. Getting? Are you getting? 2 for loop I and j. Okay. Now initially I is 0, j is 1. Inside the j for loop, it checks. Okay, j is less than ARR of I. Yes. Okay. So it swapped, and now it swapped. Okay. And j comes here. Okay. Now j is at the first position. Now if j is at the 0th position, it can't check before it, because the job of j is to check before elements. The job of j, if suppose j is here, okay, he need to check these all elements. Okay, when the j reaches at the first index, 0th index, j can't go back. Loop ends. If loop ends, I become incremented. Now j equals to I plus 1. That's why j comes here. Okay, can't go further. So I plus 1. Okay, j comes here. Fine. Now j comes here and I is 1. Now the range is up to j. The range is up to j from 0. 3 5 4. Okay, what we need to do is, if 4, same thing, if 4 is less than the previous element, yes, swap it. It becomes 3 4 5 1 2 0. Swapped, right? Swapped. Okay. J comes here. Okay, is there any element present in the LHS left hand side of J? Yes, 3 is present. It will check. If 4 is less than 3, condition false. Condition false. Again, J comes here. Why? Because in the J loop, we are using J minus minus. In the J loop, J for loop, we are using J minus minus. Okay, so J checking. Okay, if yes, then swap. If not, J minus minus. Checking. If yes, swap J minus minus. Getting? Good. Okay, so J comes here. Is there any element present LHS? No. Okay, loop ends. Go to the I loop. Okay, the for loop outside external loop I plus plus. What is the I initially? 1. Now I becomes 2. J becomes 2 plus 1. That is J is I plus 1. This is the pass 2. Ready for pass 3. Pass 3. Our array is 354120. 3, 5, 4, 1, 2, 0. Initially I is 0, 1, 2. J is this. Okay, now it's time to. No, we have already sorted, right? So the last updated array is 345120. 345120. Okay, so we have already sorted 3, 4, 5. Now it's time to sort 1. How? J is here. The job is J to check LHS, 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 LHS. Yes, then swap, 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 swap. Check. If 1 less than 5, yes, swap it. Array become 3, 4. It got swapped. So 1, 5, 2, 0. See carefully. It is getting sorted. Fine. J comes here. J is here. No, J comes here. Okay. J comes here. Okay. If J is less than 4, yes. Swap it. The updated array 3, 1, 4, 5, 2, 0. J comes here. If J is less than 1, yes. Again swap it. 1, 3, 4, 5, 2, 0. See here. First 4 got sorted. What is happening? What is happening? I told you. I told you. First this sorted, then this, then this, then this. We have reached to 1, 3, 4, 5. Okay. This is what we got. This is what we got. The next pass. Ready for the next pass. Pass 4. Okay, I hope you already got the answer. Pass 4. But I am doing it because I have promised you that I will not leave anything. That's why my video is getting so much lengthy. But it's very good to cover all the concept because I want you to crack FAANG, Facebook, Amazon, Apple, Meta, Google, and Microsoft. Facebook Meta is say 1, 3, 4, 5, 2, and 0. Now I becomes 0, 1, 2, 3. J is here. It's time to sort this. If this is less than, swap it. 1, 3, 4, 2, 5, 0. If this is less than, swap. 1, 3, 2, 4, 5, 0. If this is less than, if this is less than 1, 2, 3, 4, 5, 0. If this is less than, no, it is not less than. So just J minus, initially J is here, J minus minus. So J comes here. Okay. Now it is the last element. Fine. Break the loop. So we got 1, 2, 3, 4, 5 sorted. Similarly, ready for the pass. Pass 5 will come here, or I need to move to next page. Okay, I hope you got everything. Okay, don't complain that you have not completed. So updated array is 1, 2, 3, 4, 5, 0. I is here. J is here. Now I need to prove this. What I need to prove this? why I is less than or equal to n minus 2. J is 0. 0 is less than 5. Yes. Swap it. Okay. So J comes 1, 2, 3, 4, 0, 5. 0 is less than 4. Yes. 1, 2, 3, 0, 4, 5. 0 is less than 3. Yes. Space issue. 1, 2, 0, 3, 4, 5. 0 is less than 2. Yes. 1, 0, 2, 3, 4, 5. 0 is less than, yes. 0, 1, 2, 3, 4, 5. See, this is the answer. What a beautiful algorithm. Like means we very well know. Okay, and very simple. Only two for loop. Inner condition is check j one by one and then j minus 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 till end, till starting. Outer for loop is just start incrementing I. Okay, and rest leave as it is. Rest leave as it is. See, just we are following the same algorithm. You can see, right? Only this algorithm, only this backend, this is the operation we need to check. If j is less than previous, swap. If j is less than previous, swap. If j is less than previous, swap. Till end, I plus first again. J is less than, j is less than. Very simple. And you know, this is the one of the best algorithm to search, because you can also sort a range. Yeah, we are just sorting a range. Okay, and in the best case the time complexity is O of n. We will see. Okay, so this is what we have done. I hope you got a clear cut understanding. Okay, so now time and space complexity. Time and space complexity. What is time and space complexity? See, space complexity is there any auxiliary array we have taken? Auxiliary space. Auxiliary space means any extra array we have taken. Okay, suppose we have taken any extra array nums and then we are storing the array values into the nums. No, that means there is no extra auxiliary space, so our time complexity is O of 1. And you don't worry what is O of 1, O of n. In the linear search, I've completely explained, and I'm going to publish complete dedicated video of time and space complexity in the next upcoming lectures. So please wait. There we will see what is this and why we are writing O of n, what is omega, theta. We will derive everything. Okay, fine. So space complexity over 1 because we are not taking any extra space. If we are not taking, then it is a constant space. In a constant, we will denote constant with 1. Okay. What is time complexity? We will see worst case and we will see best case. Let's see first worst case. WORST case. In the worst case, time complexity O of n square. How? Suppose the array you are given as 5, 4, 3, 2, 1. Okay, completely reverse, and you need to sort it as 1, 2, 3, 4, 5. Completely ascending. You are given descending order, you and the question asked to sort in ascending. Okay, how to calculate n square? So n square is, okay, fine. Suppose the array is given to you as 5, 4, 3, 2, 1. Initially, what we have done? We have done one comparison. Okay, is 4 is less than 5. I was 0 and j is 1. One comparison. And then I is 1, j is 2. Two comparison. One comparison. Okay. Then one comparison, two comparison, three comparison, four comparison. What is four? N minus one. Okay, and see, I haven't proved it. What is the last I? Last I was 0, 1, 2, 3, 4. 4. Last I was 4. Okay. Total length is 1, 2, 3, 4, 5, 6. Total length is 6. Last I was 4, and after our I was 4, our array got sorted. Yeah, because our I came here. So there is no need to check in this. Okay. 4 means n minus 2. What we have written? J definitely greater than 0. J should be greater than 0. I should be less than or equal to n minus 1. It should be the end range n minus 1. Getting a point? Okay, so we are in the time and space complexity. Yeah. One comparison, next two comparison, three comparison, four comparison, n minus 1 comparison. If the array elements are not just 5, suppose n, then it should be n minus 1. Okay. So one comparison plus two comparison plus three comparison plus four comparison plus five comparison plus n minus 1 comparison. Okay. What is the arithmetic progression value of 1 plus 2 plus 3 plus 4, 4 plus 5? If you don't know, then go to Google or clear your NCERT concepts. Okay. AP, GP, arithmetic progression, geometric progression. Okay. 1 plus 2 plus 3 plus 3, 3 plus 4 plus 5, we can write it as n into n plus 1 upon 2. Solve it. N square plus n upon 2. N square upon 2 plus n by 2. This is cancelled because in time complexity, less dominating term got cancelled. It is less dominating. Why? Because if n is 1 million, if suppose n is 100, then in worst case, suppose n is 100, then this value gives me 100 square, but this is 100. Okay, the graph of n square by 2 increases in a rapid way. In comparison to n square, n by 2 is nothing. That's why less dominating term we can eliminate, cancel, eliminate it. And in the worst case, our time complexity is O, not here, the right. In the worst case, time complexity is O of n square. This is very important results. Okay, R red also, right? RGB, standard color, RGB. Okay, this is the worst case. What is the best case? Best case we have not discussed. Okay, what is the best case? Best case is simple. Best case, if array is given to us as 3, 5, 4, 0, 1, 2. Okay. No, but in the best case, suppose the array is given to you 1, 2, 3, 4, 5. Okay, we have already discussed in the past video what is the best case. Why we are calling it as a best case? Because the array is given to us is already sorted. The array is given to us is already sorted, right? Now, one note point. I and j. Okay, we will first check this. If this j is not less than, it is greater than the previous element, then no need to check further. Directly break it. Suppose my I comes here and j is here. So initially we are just checking this and then swapping, checking this and then swapping. In the insertion sort, if j failed, suppose if this is not smaller than this, directly break it. No need to check further. To checking further, it is taking extra space. See, yeah. So just like we have done here, one, okay, then two comparison, then three comparison, then four comparison. Okay, in this let's do then the same way. 1, 2, 3, 4, 5. Okay, here one comparison. Okay, here it is greater than, then no need to check here. Again one comparison. Here it is greater than this. Again one comparison. Again one comparison. Okay, till n. If the array is n, then how many comparison? N comparison. So what is the time complexity? O of n, not n square. That means linear time complexity. Time and size. So it is better. Okay, this is what time and space complexity. The next thing is stability. Okay, so yes, insertion sort is a stable algorithm. If you don't know what is stability, then in the past sorting video I have already explained in bubble sort, right? Yes, bubble sort. Okay, second thing is usage. Mostly used with shorter size of array. Okay, not for the larger length, shorter length. Okay, so stability over usage over time is and space complexity over uh, step by step debugging in pen and paper over theory over explanation over fine. The remaining thing is only CODE, code the algorithm. Yeah, this is the most important thing. Fine. Okay, so here is my Eclipse. Let me create a new project for insertion sort, or I have already created, right, sorting. Let me create a new class in this only. Why I need to create another project? Sorting, SRC, sorting, bubble sort and selection sort we have already done. The next is insertion sort, Kulja class, hmm, insertion. So this is merge sort is much more interesting, and using recursion is wow. Create a main, create a main method. Okay, what we need is we need our sorted array. So let's create array. 3, so the array 5 comma 3 comma 2 1, no, 5 comma 3 comma 4 comma 2 comma 1 comma 0, right? Hmm. Get me sorted array. Let's pass our sorted array, our array, unsorted array, and we want to print the output in the terminal. How to print the array? Arrays dot java dot in the util package arrays dot to string. Okay, fine. Okay, let's create this method. Get me sorted array. Static. Okay, what we want? Sorted array we want. So return type is array. Get me. Let's copy it. Sorted array. What we are getting? Unsorted array. That is array. Okay. Now what we have implemented in the pen and paper. Hmm. I, two for loops, I and j. If we are using two pointer, then two for loop. Okay. I and j. I less than equal to n minus 2, j greater than 0. Okay. Write the same. कहाँ आ गए? Yeah. For int I equals 0, I less than equal to what is n? Arr dot length minus 2, I plus plus. See, I'm only writing those things what I have explained, nothing, just replicating and pasting. Okay. For int j equals I plus 1. If I is 0, j is 1. I is 2, j is 3. J is 1. Okay. J greater than or equal to 0. Okay, because when j is 0, no, only greater than 0. Because if j is 0, see, I'll explain. J minus minus. Okay. Now we need to check if ARR of j, if ARR of j, if ARR of j is less than, okay, then swap. If ARR of j is less than ARR of j minus 1. See, if we write here j equals 0, so if j equals 0 here, okay, then j minus 1, 0 minus 1, that is ARR of minus 1, which gives us index outer bound exception. That is why j only greater than 0, not j equals 0. Keep in mind. If 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 this is the array 3 5 5 3, right? Oh, it is not erasing. If this is the array 5 3 4 2 1 0, it is checking here. J I is 0, j is I plus 1. It is checking here. ARR of j, that is this is less than this. Yes, 3 is less than 5. It's swapped. Okay, so now we are writing swapping algorithm. Let's create a swap method only where we are passing ARR and two indexes j and j minus 1. Yes, because we need to swap two index element. So let's pass two indices, create a static void. We are not returning swap int ARR int index 1 int index 2. Okay, how to swap? I've already shown you in the past video in the lecture. ARR of j, ARR of j, not j, index 1, right? Index 1, index 1 equals ARR of index 2, index ARR of index 2 equals 10. Sorted. Else break. And this loop. If suppose we have given an array, if suppose the array is given to us as 1 2 3 4 5 6, okay, and if j is here and I is here, suppose if 5 is less than if we will check that j, that means ARR of j is less than ARR of j minus 1, no, that means array is sorted, no need to check, else break this. Okay, why we need to check in all of this, break this. Okay, so this is what. Now let's run it. Over, over. Finally, we need to return array. Okay, because we want to return array. Return type is array. So return ARR, and it is sorted. We are printing here 534210. Output would be 101235. Let's run it. Java application 012345. Very good. Let's take minus negative elements minus 23. So minus 23 012345. Minus 23 012345. All minus. Minus 8. Minus 1. Minus 100. 110. Minus 23, 10 gain. Okay, okay, I'll take 100 also. Minus 123, minus 23, minus 8, minus 1. Okay, empty, empty, nothing, nothing. Okay, all test case will pass, and hence we got completed insertion sort. If you like the video, then please comment down, because comment is necessary. Why? Because it encouraged me to make this beautiful videos more, because we want to complete the recursion, which is the father of DSA. Okay, and I have a great real world example. I know recursion is a very strange topic. In the first time it will not understand, but I will make you understand. I have a real world example of girlfriend, boyfriend, father, and then many example, very very great, and imagination, visualize example. Okay, and then more further dynamic programming also will do recursion. There are very less channels will do dynamic programming. Okay, then graph is more important. Trees, binary tree, BST. Okay, many, all the topics. Fine. So please comment down if you like the video, because it encouraged me. Please comment down. Okay, and then like, share, and subscribe. Thank you.